Well, good evening. This is like my fourth day running on 3 or 4 hours of sleep. Just trying to get shit ready before I go out of town here. Look, I want to take a minute and I want to talk to you guys about the ldmos project. First off, I want to say this is the most expensive, time-consuming, financial suck on my business that I've ever pursued. So, we all seen about a year ago when I came out with the very first BLF 188 XR for the Funny Band, the band that we all enjoy. And, well, it's been almost 2 years now, actually. And I did a bunch of wild stuff where I was cutting a coax and running screws through the coax and stabbing a coax with a razor knife. And I even keyed one for a half an hour in the mobile application and sat there with a screwdriver and shorted out the connector. I've shot flames out the end of the bird connector with these things. The part is tough. The output aspect ratio of it is tough. But I started moving forward and I built a few of these for my own personal use and for my own personal design. I started looking at them on the spectrum analyzer. And the first iteration, the first boards, they had a setup in it which is commonly referred to as a 9-to-1 system. The 9-to-1 system is very broad-banded, but is very dirty. It creates a lot of harmonics. And that's when the problems started. Now, what I mean by that is in my pursuit of trying to not have a harmonic-based style of application, I wanted to create something that was very clean. And I wanted to do it with this ruggedized part. In that process, I've managed to discover about 9,000 ways to fail. Okay? This little guy is now Gen 3 amp 4. So from the first iterations 2 years ago, we've done several different board designs. I've had a lot of help from my teacher, Prime. Ain't no joke. Tried a whole bunch of different board designs. That man has got this technology figured out. Ain't no joke about that. I'm not interested in building any more of these. I have not taken any orders for these in forever. Actually, this one, the guy placed his order 16 months ago or so. And the reason I haven't been producing these is because I didn't want crap to be attached to my name. I didn't want to put a 9-to-1 board in there and that style of board and it be associated with a bunch of harmonics. So, through a long series of experimentations, let's say, I ended up just buying a commercial board off the shelf that met all of my requirement needs and modified it to work the way I wanted it to and put it in here, and it works wonderfully, which is a wonderful thing. And you guys that are out there that are wanting to learn how to build these, don't be afraid to buy a commercially built board, buy a BLF 188 XR, and go try it and start playing with it. That's the art of this hobby that we're in, and the fun bit of the hobby for me. Look, radio all started back in the day with guys trying new shit. And, I mean, it just makes me sad when I get on the radio and I listen to these guys and they're talking about, man, I can't wait to get my jumpers that I ordered from DX Engineering. Really? And then when they get them, they're all proud of these hydraulically crimp fit friggin' coax ends. I'm like, no. Look, I wasn't born with this knowledge. I had to go learn it from somebody else. Somebody else had to teach me how to make these and explain the circuit to me and how it worked. Then I did a bunch of reading and I got a little bit more savvy to it. And then the neat bit is that I've been able to develop a relationship where the guy that I'm working with, we go back and forth and we talk about all kinds of different stuff. To me, that's more enjoyable than anything else in the hobby, the experimentation and learning of something new. So don't be afraid of the commercial boards. There's some good ones out there. This one that's in this particular amplifier, haven't had any problems with it. I did have to modify a few things on the board that's on the inside of this thing to make it work the way we want it to. But it runs like a top. Now, let me explain to you what I mean by a financial drain. Is that this research and this fun has come at a cost. Now, each one of those transistors that's sitting there is 180, and there's a couple BLF parts that are in there, to $350 a piece. And when I say it's been expensive, it's been very expensive. And I've had bad part lots that have been delivered to me by parts suppliers. I've had all kinds of funky, weird board designs that have caused problems. But I'm not kidding. Expensive is frig. Now, I can tell you this right now, there's not going to be another amp builder in the world that's going to come out on Front Street. These were the most expensive ones. These two transistors. Those are the brand new Mac Daddy 65 volt parts. Not another amp builder is going to come out and say that they fail. Everybody's got this stupid bravado saying they were born with all this knowledge and they're way smarter than the next guy. Cool, great. Why isn't anybody else doing this? I've only seen one other video on the internet yet where the guy shows the board design and he shows the thing running at this particular band. I'm not saying it hasn't been done because the guy that taught me did it long before I came along. But now I've been standing out here for 2 years. There's $7,000 on this table right here. And that's not talking about like when the part decides it's going to go oscillate off like this. Usually it takes the power supply with it to the tune of $300. And usually it'll take and it'll screw up. This was just from one test run. This is a bunch of different diodes and capacitors, SMA components that failed on the board that we were using. Well, the boards, after you get them all said and done, $200, $300, $400 a piece. Not counting the $180 to $350 component. So we end up with today. The gentleman that owns this amp, we're going to call him Mr. A. Mr. A called me up because he's so incredibly frustrated with the amount of wait time associated with this thing. Now listen, I have not screwed anybody out of a single penny yet, and I'm not planning on doing it in the future. I finally have a board design that works very reliably and well, and we're going to start cranking these things out here probably next month sometime. So a lot of people are going to get some good Christmas presents. Because I already got the power supply sitting here, I got the cabinet sitting here. But these little guys are expensive. And I need to purchase more, which is going to happen here very quickly. But gentlemen, if your amp builder is not willing to tell you that he's failed before he succeeded, he's lying to you. And to pursue that ldmos name has been incredibly expensive and been very tough. But I'm grateful that I've had a lot of people help me, a lot of people educate me, a lot of people guide me, because it's not me. I'm not the Lord of amplifiers. But I am one of the more public ones. Let that sink in for a minute. There's a lot of entertainment value that goes along with these videos, but there's a lot of hard work on this side of the street to make it actually happen. Not to mention the phone calls, the time away from my family, and everything else that goes on to do this. So, Mr. A called me the other day very upset, and I told him, fine, I've got this board over here that I know that's working. I'm going to put it in this cabinet, and we're going to get you squared up. And I put this thing all together, got it running the other day, and I've been pretty focused on doing some other things. But he steered me back on path with this. We got this thing running, and I'm actually very pleased with how well it works, because it's so clean. Retardedly clean. But as far as you all know, this is just a chrome box. It is exactly what I say it is, though. Alright, let me get this mess cleaned up. I appreciate y'all listening to my little preamble speech here about what we got going on. Thank you for your patience. Now let's get on to the testing bit, which is only going to take a minute or two, because we've all seen these things throw arcs and sparks and farts out the other end. Oh yeah, one other thing is I've dealt with every single kind of way to fuck one of these things up that you can possibly do. From the guy on the bench all the way down to the end user when it comes to this part. And so far the biggest problem that I've had is the end user overdriving the part. These things are tough as frig on the output. unbelievably tough. Never seen anything produce the power that this thing produces and not explode. On the input side, they're a delicate little flower. They're twitchy, they're glitchy, and they're super sensitive to what you do on the input side. So this particular box is designed to have no more than 35 watts peak, or about 5 to 7 bird, period. And that's with a 1.5 watt dead key at the baseline. If you exceed that, the only thing that's going to fail in the box is the FET. Guaranteed. Just keep it in mind. Because I'm telling you guys, this is the future. We are headed that direction. Now, thank God HG has produced a decent transistor that runs fairly well, that we're able to get at a fairly decent price, and it's going to keep the hobby alive. But for my fellow ham radio buddies out there that are not afraid to experiment, they're not afraid to roll up their shirt sleeves, get their schmeckle out, turn on their soldering iron, and actually burn some solder smoke, this is the road you want to go down. I'm telling you. I'll give you an example of what I mean. This is super simple and super easy to understand. .3CX 1500 A7. 2 MOSFETs. This equals this. The future. The future. Okay, let me clean this mess up. We're going to get on with the show. Thanks everybody for hanging out for this first portion. I just had to put it out there. And to my customers, don't lose faith. I'm coming. The wheels on the train are finally moving forward on this project because, like I said, I finally got a board that I can believe in. I'll be back. Okay, now we got all that horse shit out of the way. Let's have some fun. Let's talk about a couple other things. Now, in the process of breaking these things, I've learned a lot. You guys got to understand that the 9-to-1 boards work, and they work well. And if they're not set up very specifically a certain way, you'll see 15, 16, 1700 watts out of the boards. When you look at them on a spectrum from their principal primary signal, you're going to see a lot of second and third order harmonics at just a resting carrier. And it's because the board's so broad. Now you can suppress those harmonics by building a tuned network on the output, and you can get about 1,000, 1,200 out of it fairly clean, as long as you got the right network in it. Now, thank God, the previous other amps that I built, based off of this part with the 9-to-1 setup on it, I used a lot of capacitance and a few other things, and I built a fairly deep notch window for them to operate in. That's why those amps are all out there running, except for 2 of them. One of which the guy literally ripped the cabinet off, went in and screwed with every knob and adjustment on it, and the thing blew up and somehow blamed me for it. I'll never understand that one, but somehow it's my fault. I don't know. Anyhow, they're out there running and the guys aren't having any problems with them. But once you realize that you can do things differently or better, you got to go pursue that. I've been really hesitant to build these because people just don't get it. They overdrive them. They think they're a 2879 and they think, well, I put more power in it, it's going to get more out. No, actually what happens with this part, as soon as it reaches its saturation, it won't produce anymore. And the more RF that you put into it, eventually what happens, and it happens very quickly, is you'll be seeing more and more power, and all of a sudden it just starts falling back. And when it starts to fall back, guess what? You're overdriving it. Now this particular amplifier I built safe. Okay? I put a power supply in it that is just big enough to run the part to about 98 to 99%. So the power supply is going to help protect the part from being overdriven. This has got a 10 dB attenuator built in it. And like I said, the board that's in here, it's not that I don't want to show the board or how to set the whole thing up. There's nothing in there to hide. It's a commercial board that I've modified a little bit. And of course, you know, there's really not a lot to see. The power supply runs down this side, the relay sits here, the 12 volt supply to run the fan and the relay and that kind of stuff sits up front. There's a little relay to switch the bias, and then the output board. Of course, the output board I've found that if we coat them with a rhino lining, it makes the board a whole lot more stable. Because you think about it, this thing's got to take a lot of abuse getting from me to the end user, but that black coating actually acts as a heat sink and pulls heat off the board. And we leave the part uncovered. We don't cover that with rhino lining. So we still get the air cooling effect on the top of the component. We leave the heat sink completely exposed so we don't get the saturation. I've tried all kinds of different stuff. Potting plastic, that was the worst one of them all. My God, the cabinet leaked for like 4 days till the potting plastic set up. It's to support the components on the board. There's a lot of little SMA parts and a very huge, on the 9-to-1s, there's these, you'll have 4 giant toroids sitting on there that if you got this in a car or something, they're always constantly moving, and they're attached to very specialized coax at 12 ohms. That the coax joints have to try and support the weight of the ferrites moving around, and I didn't want any of that, so I coated the things all up in plastic and stuff. But we found that the black actually acts as a heat sink, because there's no color that radiates heat better than black. Think about it. So if we don't have a coating on the actual transistor itself, we're leaving the heatsink surface perfectly exposed. The board, which sometimes will actually hold heat, has now got a better opportunity to radiate the heat away. Why do you think they painted the SR71 black? It had nothing to do with the name, I guarantee you that. It had to do with the fact that Kelly Johnson figured out that if they came up with an Inconel style type of paint, the black will actually radiate the heat away faster. Just say it. Now, most coatings you put on things are going to trap the heat in there. I get that. But it's not the source of the heat. The source of the heat is the component. Just putting that on front. So, this cabinet is special. As in, it is welded shut. And it's not to hide what I've done on the inside, because I'm pretty sure somebody eventually down the line is going to probably chisel the cabinet open or take a die grinder and cut it and pull it open. They're going to find a power supply, a relay, a BLF 188XR, and a commercial board in there that's been modified with a layer of, supporting coating that goes on the board. That's it. Not trying to hide nothing. The thing is that they're very delicate. And you can go in there and you can take that bias knob and turn that bias knob up, and guess what? It's going to put out a whole lot more power for about 1.5 minutes. And then the part's going to go boom. And when it does, the top of that transistor is going to launch off there like a missile into space. Believe you me, I've got one melted into my shop floor over here because I'm standing on rubber padding. When the lid came off, it was so hot it flew past my head, landed on the floor, and melted into the rubber padding. It's no joke. So, after having the experience, because I was drilling these screws out, I thought, well, maybe that's enough to deter people from getting in there. No. The guy that ripped mine all apart, screwed with everything on the inside, and then got all on the internet and blamed me for everything. He took a pair of pliers and ripped off the screws to get in there to play with it. So, okay, look, the thing's going to run. If it ever breaks down, send it back up to me. I got a die grinder wheel. I'll cut the damn weld tack off and I'll freaking repair the thing. I'm not leaving this part. I'm just not going to take any more orders for them. The ones that are on the books are the ones that are on the books, and there's nothing else I'm going to take about these. I'm not interested. They're too much of a time suck. They really are for me. And what my goals are for my business here, which is going to radically change in this next year, by the way. Big different. Big different, whole different game plan, going after a whole other portion of the market. Big change. I'm going to continue supporting this part as long as these things are out there and running. Now, my warranty has always been and always will continue to be, and it's on my webpage. You send it back here, you got 100% coverage on all the parts except for the transistors. Either that be Toshiba, HG, BLF, it don't matter. Think about that. Nobody else gives a warranty like that. That's because most of the components that we put in here are so tough that usually the thing that fails from improper use or abuse is usually the transistor. Okay? So, I'm going to continue supporting this component because I know the BLF isn't going to go anywhere. I mean, heck, they're still being made. But I don't want to build any more of these, you guys. I've got a couple mobile boxes. I've got the original one that's out in the wife's truck right now for her mobile. It's been running for 2 years. That's the one that we keyed for a half an hour at a 600 watt dead key with no antenna attached. Still running. Never had any problems with it. I built the 2-pill one. A friend of mine owns it. Running. Got lots of these out there moving along. Is what it is. So anyhow, let's talk about the features of this box. So, this is your standard Evercool 222 RPM bushing bearing or bushing ball bearing. See, it says ball bearing right on the fan there. Ball bearing. That moves like 25 or 30 CFM. Okay. In most applications, I would consider putting 2 of these in this cabinet adequate cooling. This particular amplifier has one of these bad boys in it. Now this isn't as loud as the camera makes it sound. It's really not. We're going to turn this on here in a minute and you're going to be like, whoa. It's not that bad. It's really not. You got to think this is going to go down on a shelf and it's going to go a ways away from you, and it's not going to be sitting here less than a foot away from the camera where the sound's going to be hitting the microphone, right? It's not that bad. The up advantage to this is the quantity of air. This is a metal body, which is great because when you put it like this in the amplifier, you've got this physical aluminum body that sits between the motor and the transistors that drive the switchers in this thing as a shield. I'm just going to leave it like this. 278 CFMs. One fan. By the way, let's see, what's this one say? 0.28 of an amp, 0.78 of an amp. Less than an amp draw. Difference between the two? Half an amp. Everybody wants quiet, but then they also want to have unlimited key down time, and they want to be able to talk till the cows come home. You cannot have both of those things. Look, I'm tired of trying to support, I want quiet, but I want 7,000 CFMs of air to move through my cabinet. That doesn't exist. It doesn't exist. Now, some of the noise that you're going to hear is from this waffle stomp lid grill that I put on here. Way better to go this route because sitting directly below this is your $200 part. Just food for thought. Fan off. Then down in here are 2 extra fans in the 1U thick rack power supply that's in here, which is an RSP 1048. Okay? Power supply can only put out max peak like 1200 watts of power. So we have a 6% or 94% efficient component. So the power supply is going to keep us right at about 1000 watts. And that's for safety on the component side of the street. Okay? The power supplies that are in here, both of them, are auto switching. And what I mean by that is you can take this plug and wire this thing up 110 or 220. You don't have to open the cabinet. You don't have to do anything. Just hook it up 110 or 220. The thing figures out what you need. Turn the on off switch on and away you go. This will run slightly better on 220 because, of course, then the switcher doesn't have to work as hard, right? That makes sense? Okay. So, let's go over here. And let's zoom in on a watt meter here. We'll bring it up full scale size for everybody. Come on, there we go. So let me show you drive. We're going to use our 2950. Oh, hold on. It's a 5-watt slug in forward position. Okay, so we've got our standard 1000-watt slug in PEP, 1000-watt slug in average, 5-watt slug in forward position. We're going to throw about 1.1 1.9, so 1.9 watt dead key. And that's where this thing will kick in. It's going to be like 1.5 to 1.9 watts. So, let's turn that back around. Let's pan over here. Hello. 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 Now what I'm demonstrating to you is the input power. Okay? Now let's go pan up here. A little bit more. Come on, tripod, you got it in you. There you go. It's the advantage is to having a nice high-end ball bearing based tripod. Thank you, Mr. Black Productions, for providing me with all this wonderful equipment to use, by the way. He's my hero and my friend. Alright, so we got our 5 watt slug sitting between our 2950 and going into, passing through, coming out, going through our three bird meters, and then into our bird 10,000 watt line section, right? Hello. 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 That's how good the pass-through tune is on it. This thing does not move. Doesn't move. Doesn't move. Is exactly what it is. That's our input tune. That was us in operation. Let me help back that up. We're going to pan back down. Now the customer is going to put about 30 watts of drive into it. I'm going to put 25 into it, and we're going to call it a day. 25 watts is going to get us about 850 to 900 watts on a pretty continuous thing. It's going to peak up somewhere around 1,000 and then slowly roll back. 1,000 watts. 1,000 watts. 1,000 watts. Alright? Zoom back in here for a minute. Now remember, the input tune isn't absolutely necessarily vital to get that down super flat, because we got a 10 dB attenuator on the input of this thing just to make it so that it can live with 35 watts of drive. Or otherwise the thing wouldn't take more than 5 watts. Okay? 1,000 watts out. We got almost no reflect power coming back from the 5 watt element there on the left. We're going to see about 200, 220 bird, and we're going to see 1,000 watts peak. And it does it all day long. Just like that. It's really simple. Now, Mr. A, I'm going to go over this, and I'm not saying anything against you personally, sir. Please don't misunderstand what I'm doing. I literally shipped one of these all the way to the other side of the United States. All the way down into the sand pile. The guy gets it, plugs it in, turns it on, and sends it back because he says it's not working. On turns on all your power supplies and your fans. Operate is what makes the thing key with the auto keyer. This is your sideband delay. He didn't understand what the switch was and never flicked it. So I just want to cover that. Just saying. Because it happened. Never in my wildest dreams, but it happened. I shipped a bass amplifier out to a guy once. He got it on his side of the street and said it wasn't working. He said he keyed it up and it lasted for about half a second and wouldn't put out anything else. Turned around and sent it back. It was a blown fuse. Just saying, of course. Now look. The fuse is in this back left corner. Okay? It's a simple push lock. And there it will come equipped with a single 15 amp fuse. Harbor Freight fuses are cheap and they work just fine. Just saying. Just so you know. You ground this thing, you're going to have all kinds of fun. yeah, that's it. Mr. A, you're done. It's got the standardized 4 feet on the bottom of it for noise isolation, which you're going to want with the power supply that's in this. And a single 150 plus CFM blower, basically. Now, I got another buddy of mine. We're going to call him Mr. P. He wants me to take the 4 fans out of his 24 pill, and he wants me to put 4 of these things, plus add 2 more into his 24 pill. I said, now, bro, does it really get that hot? He goes, well, no. I talk on it for 2 or 3 minutes, and the air that comes out of the cabinet's fairly warm. Okay. I just wince, and I go, okay. So I think what I'm going to do is I'm going to hopefully get him convinced that he only needs 4 of these fans, taking into account that 1 fan puts out the same amount of power as all 4 of the standard 120 millimeter fans. Just saying. He'd probably be better off if he just let me put 2 of those fans in there. But more is better, and sometimes that's the way it needs to be. Anywho, maybe he'll have me cut a hole in the lid and put a blower on it. That'd be awesome. Talk about unlimited key down time, man. That's cool. If you run it the way that I just demonstrated to run it with about 25 to 30 watts of drive, you literally will have as much key down time as you can handle. This thing will just run. And it's because of that high CFM blower and a big heatsink that the thing's mounted on. I mean, we're talking a little tiny part about that big. That's the total surface areas from this digit down on a heatsink that's this big. That's forced air cooled. Laminate flow, top and bottom, right? The only thing that could have made this thing any better is we put, like an inch thick copper spreader on there, and then inside that copper spreader we put a chiller bar and a whole bunch of other wonderful fun goodies that cost more than what the whole amp costs if we just do it air. We're trying to dissipate 150 watts to 160 watts worth of heat generation for every second of operation. So we're trying to dissipate roughly the heat of a light bulb at the element. Not the surface temperature of a light bulb, like at the element. So, is what it is. Look, guys, I'm going to call it. This has been an insane last couple days, and this whole weekend has been crazy. I got a bunch of other fun projects coming up. It's going to be a lot of wham bam, thank you ma'am stuff from now until I get ready to go. This is going to be an interesting week, and it's going to be a lot of fun, and we're going to cover a lot of ground. And I appreciate everybody listening to me just dribble on here and talk. I want to thank you for all time. Gentlemen, my name is BBI. I don't get to be here without all of you. I don't get to be here doing this stuff. Hell, I don't get to be standing in this garage talking to my camcorder without your all support. And that's the honest to God truth. Without you, I don't exist. Without you guys sending me projects to work on and trusting me to build you stuff, I'm not here no more. And it's the same way with every single other builder in the world. The only difference is I do mine on Front Street. Hey guys, if you haven't had a chance, go check out Scorpion Radio. Scorpion Radio Repair. He's out of California. He's a good friend of mine. Make sure to go check out Hopperbuilt. Mr. Nate Jones, he's a good guy too. And Mr. Tech 9, I know you and your brothers are down there watching me, and I appreciate your guys' support and your love. Because me and Tech 9 is no joke, we're like this. We are friends. And I want to just give a shout out to all my supporters out there and my friends. Guys, I thank every single one of you from the bottom of my heart. I'm going to move on and go do some other shit. From the biggest mud duck in Idaho, I'll see ya. Bump bump. And if this is the first time you've ever watched one of my videos, click subscribe. I do cool shit all the time. I'll see you, bye. Okay, let me show you some things. It's going to be our temporary stand. I got my network analyzer out. Let me show you some stuff here. So we got centered, and our amp signal is at focus at -20, so more than sufficient. We are from 31 to 22 megahertz, right? And I want to show you a spectral shot. How we're achieving our signal pickup is off our line section. So we've got our radio, comes down, goes into our amp, goes through our amp, comes out the back of the amp through a piece of RG400, and goes through all the line pickups. And what we've got here is a coaxial dynamics attenuator line pickup. So it comes directly off, goes through some 316 coax and dumps directly back in here. Now I got this set intentionally hot for a reason. Okay? What I'm going to do is I'm going to rip over here and I'm going to grab the microphone. And I want to show you what the radio looks like just on its own. So now please take note of where all the little harmonic humps are at. Because remember, the amplifier is only going to rectify what we put into it. So we've got our primary principal, then we've got a secondary, and another little tiny one down here, and another little tiny one down here. Okay, now what you don't want to see is when you put the thing into operation, you don't want to see it creating a bunch of other spurious garbage, like you'll see a harmonic here, and another one here, and another one here, and another one here, and another one here. We just have our principal, so this will be what we consider to be our principal shot. Okay, and as it's picking up just a little bit of side, you see a little bit of the side bands presenting themselves off the primary signal. So we got a little bit of a spike there, a little bit of a spike there, and a little bit of a spike there, which is not too bad. So when I turn the amplifier on, what we should see is this exact same signal replicated, but with a stronger signal strength. Okay? All right. It's clean. It's clean. That's all there is to it. It's clean. Put the amp in standby. Operate. Standby. Operate. Standby. Just putting that out there. Just thought you all would want to see it. Anyhow, I'm out. I'm going to go do some other stuff, work on some other shit, make some other people happy, and get on with it. I'll see you guys. Bump, bump.